In this lesson, we'll learn how to use equations to fill out tables with both inputs and outputs missing. Let's use this equation to fill out this table. We notice that they give us 3 inputs for the x's, and we need to figure out the outputs, or the y's. So let's do this one at a time. We have, the rule says 1/4 times x plus 1. So that would be 1/4 times x, which is 4, plus 1. Well, let's just rewrite this to review multiplying with fractions as times 4 over 1. We can multiply across the top, 1 times 4 and 4 times 1, so that'll be 4 over 4 plus 1. And a fraction is also a division problem. So this is 4 divided by 4. So we have 1 plus 1. All right, so with an input of 4, the output is 2. With an input of 8, well, that would be 1/4 times 8, or times 8 over 1, plus 1. So that'll be 8 divided by 4, plus 1, or 2 plus 1. So when we have an input of 8, we have an output of 3. And finally, when we have an input of 12, we have 1/4 times 12 plus 1. Well, that would be 12 divided by 4 plus 1. Well, 12 divided by 4, that's 3. So when we have an input of 12, we have an output of 4. With this table, we actually have a different situation. So we have our equation, but in the table, the inputs are missing. The x's are missing. And they tell us the outputs. So in this situation, we'll be working backwards. So what this is saying is that y equals whatever x is plus 3. So I'll start with my y. I have 4 equals whatever x is plus 3. All right, so we need to figure out a number that when we add 3 to it, we end up with 4. Well, that would be the number 1, wouldn't it? Because 4 equals 1 plus 3. So in this case, the input needs to be 1. Now we could also do this by solving the equation. We can use our inverse operations, subtract 3 on both sides, and get x equals 1. All right, so here we have an output of 8, so we have 8 equals some number plus 3. Well, let's see, we know that 8 equals 5 plus 3. So the input must be 5. And then here we have our y, which is 5, equals some number x plus 3. Well, let's see, we know that 5 equals 2 plus 3. So x must equal 2. So the input is 2. So notice in each case here, the y is 3 more than the x. 1 plus 3 is 4, 5 plus 3 is 8, and 2 plus 3 is 5. Here we have the inputs missing again. The rule is a little bit different. It says y equals whatever x is divided by 4. All right, so here we have y, which is 4, equal to some number divided by 4. Let's see, we need to have a number divided by 4 and end up with 4. Well, that would be 16 divided by 4. So x equals 16. So when we have an input of 16, we divide it by 4 and get our output. Well, let's try this next one here. So we have our y is 2, so we have 2 equals some number x divided by 4. All right, so we need to find a number that when we divide it by 4, we end up with 2. Well, we know that 2 equals 8 divided by 4. So x must be 8. We're cruising right along here. We have some number, or we have 9 for our y. That's going to equal some number x divided by 4. Okay, so we need to have a number, divide it by 4, and end up with 9. Well, this is going to be a little bit bigger here. And we know that 36 divided by 4 equals 9. So x must be 36. So we have an input of 36, we divide it by 4, and end up with our output of 9. Something a little different happens here. The rule is y equals 5 times whatever x is. So here we have our y, it's our output, and that's going to equal 5 times some number. All right, so we know that 5 equals 5 times 1. So x must equal 1. So we have an input of 1, we multiply by 5, and we get our output. So here we have our y is equal to 4. That's equal to 5 times some number x. As we think through that, well, 5 times 1 is 5, 5 times 2 is 10. There isn't a whole number we can multiply 5 by to get 4. Well, this 5x means 5 times x. And we're going to work backwards to figure out what x is. So we're going to divide by 5 on both sides. And by both sides, we mean on both sides of the equal sign. And we do that because 5 divided by 5 equals 1. So now we're left with 1x. So we have 4/5 equals x. So when we have an output of 4, the input needs to be 4/5. Right, now we want an output of 2. So we have 2 equals 5 times x. Let's see, we're working backwards to figure out what x must have been to get an output of 2. So we'll divide by 5. And we can do that because we're doing it on both sides of the equal sign. And we end up with x equals 2/5. So to get an output of 2, we must have had an input of 2/5. On our last example here, the rule says to get y, we subtract 1/4 from x. Well, here we have 13/4 for our input, our x. So we have y equals our input minus 1/4. Now, conveniently, we already have common denominators. And when we have common denominators, we subtract the numerators, 13 minus 1, and keep the same denominator. Now, this fraction, we can treat it like a division problem. It's 12 divided by 4. So we get y equals 3. So when our input is 13/4, our output is 3. All right, now here we have an input of 2. So we have y equals 2 minus 1/4. So we just have some arithmetic to do here. We can turn the whole number into a fraction. And now we can get common denominators by multiplying the top and the bottom of this fraction by 4. That'll give us a denominator of 4. And multiply across the top to get 8. Multiply across the bottom to get 4. And so the number 2 is the same as 8/4. So we have 8/4 minus 1/4. Here we have a subtraction problem with common denominators. So we keep the same denominator and subtract the numerators. So we have 8 minus 1 is 7, and keep that same denominator. So when we have an input of 2, the output is 7/4. Last one is we end up with an output of 3/4, and we're trying to figure out the input. So our y equals 3/4. That's what we end up with. We're trying to figure out what number do we subtract 1/4 from to end up with 3/4. Well, we're working with fourths here. And so to end up with 3/4, we would have to start with 4/4 and subtract 1/4 to end up with 3/4. So x must equal 4/4. But 4/4 can be simplified. And 4 divided by 4 equals 1. So when we have an output of 3/4, we have an input of 1. I hope these examples about filling out tables have been helpful. This is Mr. Ela, signing off.